examining the hydroclimatic drivers of lagoon breaching and healing in a deltaic barrier. Welcome to Journal Club. The latest academic research, explained in plain English. Today we're looking at this paper from MDPI's Journal of Geosciences. It's authored by Gomez, et al., from the University of Victoria in Canada, and is published open access under a CC BY license. Let's start by translating the title into more accessible language. When you read this title, you can understand it to mean in very simple terms that this paper studies the reasons why lagoons in a deltaic barrier break and restore by looking at the water and weather patterns that cause them. Let's expand on that a little. The research paper investigates why lagoons, or bodies of water separated from the ocean by a sandy barrier, sometimes break through that barrier and mix with the ocean water. The researchers are looking at how changes in the weather and water patterns, such as heavy rainfall or tidal changes, might cause the lagoons to breach or heal. The study is focused on a specific type of sandy barrier called the deltaic barrier. Now we understand the title, which is a good start, but before we can break down the full paper, we'll need to catch up on some terminology, jargon, background information and context. Specifically, there are some key concepts you'll need to be familiar with. Let's define them now. Deltaic barrier. A landform created by sediment deposition at the mouth of a river where it meets an ocean or sea. Coastal erosion, the process by which coastal lands and features are worn away by waves, currents, and other natural or human-induced factors. Lagoon, a body of shallow, enclosed seawater separated from the open sea by a barrier or reef. Breaching, the process by which a lagoon is breached or connected to the open sea due to natural or human-made factors. Healing, the process by which a breached lagoon closes naturally and is once again separated from the open sea. Atmospheric conditions, the state of the atmosphere in terms of temperature, humidity, pressure, wind, and precipitation. Oceanographic conditions, the physical, chemical, and biological characteristics of the ocean, including currents, tides, and salinity. Fluvial conditions, the characteristics of a river and its flow, including discharge, sediment transport, and channel morphology. Coastal retreat, the process by which the shoreline moves landward due to factors such as sea level rise and erosion. Now that we understand the title and key concepts, we're ready to dive in and break down this paper. In this presentation we're going to attempt to answer 5 questions. 1. What were the researchers trying to figure out? Or more specifically, what was their hypothesis? 2. How did they conduct their experiment? That is, how did they test their hypothesis? 3. What were the results of the experiment? 4. What conclusions did the authors draw from those results? And lastly, 5. Why does this research matter? Why should you care? 1. What were the researchers trying to figure out? The researchers hypothesized that lagoon breaching and healing events along the Magdalena River deltaic barrier are driven by short-term hydroclimatic conditions, such as extreme river discharges and energetic wave conditions associated with storms or hurricanes, and sediment supplied by littoral currents and average waves punctuated by energetic events. 2. How did they conduct their experiment? The researchers compiled a database of hydroclimatic data including wave conditions, wind velocity and direction, precipitation, and river discharge for the period 1973 to 2020 to examine their influence on lagoon breaching and healing. They obtained hourly measurements of these variables from meteorological and flow gauging stations managed by the Colombian Institute of Hydrology, Meteorology and Environmental Studies, IDEM. They used Landsat satellites to track changes in lagoon size as well as the timing and extent of inlet breaches and duration of healings during the same period. They also quantified barrier width and coastline changes using the Digital Shoreline Analysis System (DSAS) and analyzed variations between event and non-event hydroclimatic conditions to quantify the influence of meteorological forces on the landscape, using the difference between event and non-event medians expressed as a percentage of overall visual spread, OVS. 3. What were the results? The researchers found that coastal retreat has led to a reduction in the area of the 4 lagoons studied, with the seaward limit moving landward. 3 out of the 4 lagoons experienced breachings during the study period, with most breaches occurring after a period of increased wave energy and larger than average sea level pressure gradients. Coastal erosion rates were higher in the Cuatro Bocas sector, where breachings occurred more frequently and healed faster. The researchers also observed changes in the areal extent and shape of the lagoons over the study period. The El Torno Lagoon had the largest inlet length in 1973. 4. What conclusions did the authors draw from their results? The study found that short-term drivers, such as storms and river discharge, can cause different effects along one stretch of coastline due to variations in morphology and sediment supply. Breaching of the barrier lagoons is most likely to occur in narrow sectors located updrift of longshore sediment supply, and healing occurs following stormy conditions but may take several stormy seasons, particularly when the breached inlet is wide. The cumulative impact of breachings and healings has caused the landward displacement of the coastline, resulting in a reduction in barrier width and changes to the aerial extent of the lagoons. 5. Why does this research matter? The findings provide a better understanding of the forces of coastal retreat, particularly the impact of storms, river discharge oscillations, and energetic wave conditions associated with hurricanes. This work will help inform future management decisions of the coastal zone and aid in developing strategies to mitigate the effects of coastal erosion and preserve critical ecosystems. We hope you've enjoyed this Journal Club presentation of examining the hydroclimatic drivers of lagoon breaching and healing in a deltaic barrier. If you'd like to read the full paper yourself, which we encourage you to do, you can find it at DOI 10.3390/Geosciences 13040118.